Chapter 17, Problem 19. A solid mixture contains magnesium chloride and sodium chloride. When 0.5 grams of this solid is dissolved in enough water to form 1 liter of solution, the osmotic pressure at 25 degrees Celsius is observed to be 0.3950 atmospheres. What is the mass percent of the magnesium chloride in the solid? Assume ideal behavior. So we have a solid that weighs 0.5 grams. And so some of it is going to be magnesium chloride, and some of it's going to be sodium chloride. So we don't know how much of each. So let's say we have X grams for magnesium chloride. Instead of putting Y for the sodium chloride, I'm going to put 0.5 minus X. Second, we're dealing with osmotic pressure. So osmotic pressure is I molarity RT. Now, typically when we use this equation, we just have one solute, but we have two solutes with two totally different I values. So it's like, well, which one do we use? So I'm going to adjust for that fact with my equation. So molarity is moles per liter. And so what I'm going to do is I for MgCl2 times the moles of MgCl2 plus the I for NaCl times the moles for NaCl all over the liters of solution times R times T. So basically I distribute the I due to the fact that I have multiple solutes. Now, I don't have those moles because I don't have those grams. So I'm going to convert to moles, but I'm going to do it using algebra. So they tell us that the solution has an osmotic pressure of 0.395. So the I for MgCl2 is 3. And to get the moles, I would take X grams and divide it by his molar mass. So the molar mass of MgCl2 is 95.22 grams per mole. Then the I for NaCl is 2. His mass is 0.5 grams minus X grams. And his molar mass is 58.44. And then all of that over 1 liter times R. So since they gave me osmotic pressure in atmospheres, I want to use the little r and change my temperature into Kelvin. So technically the chemistry is done at the point when you're like, oh, I've got to use the osmotic pressure equation. All the rest that I'm doing here is going to be algebra. So if we solve for X, what we end up getting is 0.35 grams. Now, X we designated as MgCl2. So the question wanted us to figure out what was the percent of MgCl2 in the solid, specifically the percent by mass. So the percent of magnesium chloride, we had 0.35 grams out of 0.5 grams of solid. So 70% of the solid is magnesium chloride. By default, then 30% is sodium chloride, but they didn't ask us that.